Hey Panthers. So the next module after there's ratios, equivalent ratios, unit rates. The next module after that is scheduled to be percents. But I looked at the percents module and I thought, man, before you solve these percent problems, because they're kind of tough, you need to understand proportions. So I thought I have to put my own module in there to teach you about proportions first. But in order to solve proportions, you need to solve one-step equations. So I've got to teach you one-step equations so that I could then teach you proportions so that then we could do the percents module. So this module is all about one-step equations, so you can learn that first. So in your notebook, we're going to do one-step equations. So you can put down the date. The date is 9/16 for me. One-step equations. See what page number you're on. I'm on page 11. So find the page that you're on, one-step equations, the date, set that up, go to your page in your book, and you're gonna write this on that page. Okay, so we got solving one-step equations, write that as your title. Okay, so to solve one-step equations, I want you to use inverse operations. Now, some of these equations are gonna be like so simple you can do the mental math, but my job is to get you ready for solving the ones that you can't do with mental math. So don't think like, oh, I've got my own way, my way's a shortcut. Don't do that. I'm trying to teach you this way to get you ready for other stuff that you're going to do in the future. So I want you to solve it using inverse operations. Now, inverse operations means opposite operations. So like the opposite of adding is subtracting. The opposite of subtracting is adding. Those are inverse operations. The opposite of multiplying is dividing. The opposite of dividing is multiplying. They are inverse operations. So these are the inverse operations you want to be using right there. Okay, write that down. After you've written that down, write this down. If you add, subtract, multiply, or divide one side of an equation, you must do the same to the other side. So it's like keeping the two sides balanced. So if there are two things that are balanced, let's say it's like a seesaw, and the seesaw is balanced. If you add 5 pounds to this side, it's not going to be balanced. Unless you add 5 pounds to this side, then it will be balanced. So if you add 5 to both sides, it's okay. If you take away 10 pounds from this side, it won't be balanced anymore. Unless you take away 10 pounds from the other side, and then it will be balanced. If you triple this amount, it will only be balanced if you triple this amount. So that's what this says. If you add, subtract, or multiply, or divide one side of an equation, to keep it balanced, to keep it equal, you've got to do the same to the other side. Okay, now in a second, I'm going to erase this so I have more room to write. If you need to catch up, pause the video, get this written in your notes. All right, so you've written that. Next, you want to bring down the equal sign. And you want to start by looking at the side with the variable. The variable is the letter that's there to represent a number. Okay, so you're going to bring down the equal sign. You're going to start by looking at the side with the variable. And again, the variable is the letter that represents a number. We use variables in algebra. Okay, I'm going to show you a few examples about how to actually apply this into solving these one-step equations. Make sure you're caught up. I'm going to erase this in a second, so pause the video if you need to pause it to write that down, and we'll do some examples of solving one-step equations. Okay, like here would be like a really simple one. Let's say it was like 5 plus n equals 7. That's about as easy as it gets. So this is a variable. It's a letter, but it represents a number. I think it's very obvious what number this represents. We all know that 5 plus 2 is 7, so we know that that number represents 2. But again, I want to teach you how to solve ones that are not so easy. So I still want you to learn how to do it this way. What we're going to do is there's an imaginary line right there. You could either draw the line like I just did, or you could keep it imaginary. But if you look at the steps, it says to bring the equal sign down. So this equal sign will come straight down there. Then it says start by looking at the side with the variable. So is the variable on the right side or on the left side? It's over here on the left side. Okay, so remember it says use inverse operations. What is the inverse or opposite of adding 5? Because they're taking the variable and they're adding 5. The opposite of that is subtracting 5. But then remember, if we want to keep it balanced and keep it equal, that means we're going to have to subtract 5 from both sides, otherwise it won't be equal. So if we're going to subtract 5 from this side, subtract 5 from the other side as well. Because adding 5 and subtracting 5 are opposites, I just cancel that out. That basically equals 0. So then everything comes down. Just like when we did the order of operations, we bring our work down. So we bring down the n, we bring down the equal sign. There's no more 5 because those are opposites, and this equals 2. Again, we already knew the answer was 2, but this is the way I want to get used to showing your work. Okay, next example. This one, maybe not as obvious. Let's say it's 2,317 equals W plus 898. Okay, so what number can you add to 898? And the answer is 2,317. Again, not as obvious as the last one. So, but we still solve it the same way. Imaginary line right there. Bring the equal sign down. Should we look at the right side or should we look at the left side? We look at the side that has the variable. So in this case, that's the right side. We want to do the inverse operation or opposite operation. What is the opposite of adding 898? It's to subtract 898. But if you want to keep them equal and keep them balanced, if you take away 898 from this side, you got to do the same to the other side. Now, since these are opposites, I just cancel that out. They basically will make each other equal 0. Bring everything down. Bring down the W, bring down the equals, figure out what this is. To bring that down, I got to do some borrowing in there. $1,419 is the answer. So if you take that and plug that back in for W, 1,419 plus 898 is equal to 2,317. Okay, now both those equations we just did both had adding, so we solved them with subtracting because that's the inverse. But they could be adding, subtracting, multiplying, or dividing. Let's do some other examples. Okay, let's say the original equation is 54 equals n minus 32. Okay, so what number could you minus 32 and it equals 54? And there's an imaginary line right there. Let's say I'm going to keep it imaginary. I'm not going to draw it. That's fine, as long as its equal sign comes straight down on that imaginary line. So there's two sides. There's a right side and left side. We're going to look at the right side because it has the variable. What is the inverse or opposite of minus 32? It is to add 32. What side are we going to add 32 on? The answer is you got to add 32 on both sides. What am I going to do with the minus and the plus 32? Cancel them out. Bring down the n. Whatever this is, you bring that down as well. So I'm going to bring down the answer, which is 86. 86 equals n, and that's how to solve a one-step equation. Okay, we did adding and subtracting. Let me show you what multiplying looks like. And in fact, I told you earlier, the reason I'm teaching about one-step equations now is because I want you to learn proportions in the next lesson. And to solve proportions, you're going to need to know how to solve these equations. Specifically, you need to know how to solve the ones that are multiplying. And we haven't done a multiplying one yet. We're going to do it right now. What you need to know is this. If you get to an equation, something like this. 8n equals 2,600, I'll make it like that. Okay, 8n equals 2,600. Okay, what you need to realize is this. When you have a number and it's right next to a variable, that actually means multiply. So you probably didn't know that yet. I'm telling you now. When it's 8n, that means 8 multiplied by n. Okay, so this problem is 8 multiplied by n equals 2,600. Okay, so here's what we do. Imaginary line right there. Bring down the equal sign. Again, we have to know that this means multiply. So, oh, by the way, why am I looking at this side instead of this side? I'm looking at this side because it has the variable. Look at the side with the variable. Okay, so what is the inverse or the opposite of multiply by 8? It is divide by 8. Now, in algebra, you're usually going to see a fraction bar as a division sign. So a fraction bar means divide. This means divide by 8. What side am I going to divide by 8? The answer is both sides. Divide this side by 8 as well. Okay, now, if you're multiplying by 8 and dividing by 8, they cancel each other out just like it did when it was adding and subtracting. And then when you think about it, many of you know that 8 over 8 equals 1. So that's just 1n. And 1n is just n. Okay, so the 8's get rid of each other. The n comes down. I got to figure out what is 2,600 divided by 8. To be honest, I don't know what the answer is to that. So I can do some scratch work off to the side. When you do the scratch work, don't do it by the problem. Do it away from the problem. I'm trying to figure out what is 2,600 divided by 8. So I'm going to use this division sign to figure that out. So blank, 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 blank. By the way, when you get to the percents lesson, I'm going to let you use a calculator. So you could actually just do that in the calculator. But right now, I'm not going to use a calculator. I'm going to figure this out. 8 doesn't go into 2. 8 goes into 26 4 times. Nope, sorry, 3 times. 3 times 8 is 24. Subtract, bring down. 2, that's 16. Subtract, bring down. It's 325. Now that I know that's 325, I bring that down. There we go. So it turns out 8 times 325 equals 2,600. Let's do 2 more examples. All right, in this example, let's have 15 is equal to, let's see here, we'll do 6, W divided by 6. 15 is equal to W divided by 6. Now, many of you might kind of freak out and go, oh my God, it's a fraction. I can't do fractions. But check it out. It's not really a fraction. It's really a division problem. Because remember, a division problem is a fraction. So W over 6 is W divided by 6. 15 equals W divided by 6. All right, so here's how this works. Imaginary line. Writing down the equal sign. All right, we're going to look at this side because it has a variable. What is the inverse or the opposite of divide by 6? The opposite of divide by 6 is multiply by 6. Now, because this is divide by 6 and this is multiply by 6, those are opposites. They cancel each other out. The W comes down. But if you're going to multiply one side by 6, you've got to multiply the other side by 6 as well. So when you solve this, you can bring it down. That's going to be your answer. So when you multiply this, you get 90. 90 is equal to W. So now we've done one-step equations when there was adding, when there was subtracting, when there was multiplying, and dividing. Which one of those did I say is going to be most important when it comes to solving the percent problems and the next couple lessons that I give you? Was the adding, subtracting, multiplying, or dividing? If you said multiplying, you're right. So let's practice one more multiplying problem and then we'll wrap it up here. Let's say we had one that was 830 is equal to 12R. Okay, so one thing you have to realize is what does it mean when the number is right by the variable? 12R, there's no symbol in between, just 12R. You need to understand that means multiply. This is 12 multiplied by R. All right, so imaginary line, equal sign comes down. Do I look at this side first or this side first? Want to look at the side with the variable first. Then ask yourself, well, there's a 12 there. I want that 12 to go away so the R could be all by itself. So I've got to do the inverse operation. Are they adding 12, subtracting 12, multiplying 12, or dividing by 12? They're timesing 12. So the opposite of times 12 is divide by 12. In algebra, you're usually going to see this division sign instead of like this division sign. So I'm going to use this division sign. So divide by 12 there, divide by 12 on the other side as well. Okay, the 12s cancel each other out. The R comes down. Now I got to figure out that. I really don't know what that equals, so I'm going to do my scratch work off to the side. Okay, I got 69 with a remainder of 2. So if you remember, I could actually make that 2 into a fraction. I can make it 69 and 2/12. And I could simplify 2/12. So I could make that 69 and 1/6. So 69 and 1/6 is the value of R. All right, so that's the lesson on one-step equations. It's bring down the equal sign, pick which side to start on, do the inverse operation, which is the opposite operation, and whatever you do to one side, you gotta do to the other side. Bring everything down, and you'll have your solution. All right, awesome, Panthers. So next we're gonna use these one-step equations when we learn about solving proportions, and then we're gonna learn about how solving proportions will help us with percents. And that's all coming up very soon. Take care.